Problem number 13. A millimolar aqueous solution of potassium ferrocyanide has the alpha, it's a degree of dissociation, 80%. The osmotic pressure of the solution at 27 degrees Celsius will be. Options are A. 1.05 into 10 power 4 Newton per meter square. B. 2.5 into 10 power 3 Newton per meter square. Option C. 8 into 10 power 5 Newton per meter square. And D. 7.8 into 10 power 4 Newton per meter square. The osmotic pressure pi is equal to CRTI. I is the Van der Waals factor. So we have to calculate Van der Waals factor first. So I is related to degree of dissociation. So alpha is equal to I minus 1 divided by n minus 1. N is number of particles obtained from a single molecule of the electrolyte. Here alpha is given 80%. So 80 divided by 100 is equal to I minus 1 divided by n minus 1. N minus 1 for potassium ferrocyanide, if we dissociate, the n value is 5. Potassium ferrocyanide dissociate into 4 potassium ions and 1 complex ion, because the formula is K4FeCN 6 times, and this is the complex ion. FeCN6 is a complex ion. So when this molecule dissociate, 4 potassium ion and 1 complex ion will be formed. Therefore n value is equal to 5 here. So I minus 1 and here 5 minus 1. So 80 by 100 is equal to I minus 1 divided by 5 minus 1. Solving for I, we have the value I is equal to 4.2. 4.2 is the Van der Waals factor for potassium ferrocyanide. Now that osmotic pressure pi is equal to 0. C, the concentration given as millimolar, therefore 1 by 1000. 1 by 1000 into R 0.0821 into temperature 300 Kelvin. Now the same thing would be multiplied by the Van der Waals factor 4.2. So we have now the osmotic pressure in so much atmosphere only, that is 0.1034 atmosphere. That's the, we solve this, you will get this answer, and 0.1034 atmosphere must be converted into SI unit, because all options are given in SI units. So 1 atmosphere is equal to 1.013 into 10 power 5 Pascal or Newton per meter square. So 0.1034 atmosphere must be converted into Newton per meter square. That too, you have to multiply with 1.013 into 10 power 5. So on solving that, you have the value 1.05 into 10 power 4 Pascal or Newton per meter square. 0.1034, you have to adjust the decimal and the power also. So 1.05 into 10 power 4 Newton per meter square. So the option is 1.05 into 10 power 4 Newton per meter square. That of the all the options, see A, B, C, D, A gives the correct value. So 1.05 into 10 power 4. So this satisfies our condition. So go for the option A.